And so this just gives you a ballpark, like 0.1 to 0.2 grams. That. And then you're going to weigh that out. And so let's say here I weighed out 0.1234 grams of unknown acid. And then since we are measuring the pH, you can dissolve this in any amount of water you want. Right? And so the amount of water is not critical here. And then you're going to add, 1 to 3 drops of phenolphthalein. And then we're going to titrate this. And so let's say 22.13 milliliters of sodium hydroxide were required to titrate 0.1234 grams to the end point. Then that's pretty close, But what we want to do is we want to have the we want to use the maximum amount of sodium hydroxide, which would be about 30 or 35 milliliters, to reach the end point, because we want to go past the end point. And so here, what we're going to do is we're going to calculate the mass of acid required for 30 milliliters, let's say, to hit the end point. All right, so that means X grams over 30 milliliters will equal 0.1234 grams over 22.13 milliliters, after I do the titration here. And so X grams will be the optimum sample size. And so depending on the accuracy of your trial titration, this is what you're going to do. Your trial titration is going to say that the equivalence point should come in at 30 milliliters. For diprotic acids, it works like this. If you had a diprotic acid, the first equivalence point has a pH less than 7. The second equivalence point would have a pH greater than 7. If you have a monoprotic acid, the equivalence point will have a pH greater than 7. And so what we're doing here is with phenolphthalein, that will get this second one. The first one will be invisible for diprotic. And for phenolphthalein, monoprotic will be visible. pH greater than 7 should be fine. In fact, that should be good, really good for phenolphthalein. And so that means around 30. And so what you're going to do is let's say you're going to take larger intervals until you get close to 30. Let's say at 29, depending on how accurate you think your trial went. If you think you're really good, then you might stop around 29 and go drop by drop. If you think there might be some error in your trial, then you might want to stop earlier, like 28, just in case. Right? You don't want to pass it. A lot of people, what happens is they take large intervals and oops, they passed it. Well, if you pass it, you have to scrap it and start over again, basically. All right, we don't know if we have a monoprotic or diprotic, so that means at 15, you have to stop before 15 and go drop by drop. So here you'd stop at 14 or maybe 13 milliliters and go drop by drop. Right? So this is what we're going to do. Now, once you have your optimum sample size, then we're going to set up the pH titration. And what you're going to do is at the large intervals here, you'll go, half to 1 milliliter, then stop, go drop by drop, and then resume half to 1 milliliter, and then stop, drop by drop, and then once it peaks out up here, where it kind of stabilizes out, then you go 1 milliliter, and then maybe at the end you could go 2 milliliters or 5 milliliters, depending on, this is going to be pretty flat here, so you won't see much change in the pH. Uh-huh.
So, finding the optimum sample size now, this is just, I don't understand why, really, because what if it's a diprotic acid will be more, right?
No, diprotic is the same. It's gonna be the same because for diprotic we're gonna hit the second equivalence point. And so we want the second equivalence point to be around 30 for diprotic, and we want the first, or the only equivalence point of monoprotic to be around 30. This means we have 20 mils we can go past the equivalence point and see the complete curve. A lot of people, they stop when they see the phenolphthalein turn pink. And so their whole titration curve looks like this because here's where the phenolphthalein turned pink and they stop there. And we don't see the rest of the curve. You know, but we want to see the rest of the curve. That's why we're going to leave 20 more milliliters to go beyond it. And so that we can see the rest of the curve all the way out to about 50 milliliters. All right, any other questions? So this is what we're going to doing. What we're going to do on Thursday. Is that clear enough to get started? So I decided I'm not going to pass out a handout for this. I mean, this is pretty much the experiment right there. All we want to do is we want to get a nice, well-resolved titration curve with high resolution near 15 and 30 and coarse resolution in between, okay? The prep of the notebook is pretty simple, just trial titration or something. You don't really have to prep it much. The procedure is not that complicated, I think. All right, so that's it for me talking. Just go ahead and finish up the lab. If you already finished the lab, just let me check off your notebook for today. If you already finished the lab and you want to do some more, you can make some more buffers to see how those behave. Okay.
Then the leftovers I'll keep them for him and give it to him later.
Okay. Thank you.